Alright guys, welcome to chalkuniversity.com. We're going to be covering today the first sequence in linear algebra. And the videos are basically broken up into two parts. One part will be more theory and proof, and the other videos subsequently following it will be based on examples, and they'll be quite short. This way you don't have to go through like a whole bunch of like one long video. We're going to be covering complete relevant theory and worked out examples. Most of the important theorems will be stated but not explicitly proven. We want to keep your emphasis sort of like on how to solve the problems, and this will help you develop an intuitive feeling for most of the concepts. So what is linear algebra? Linear algebra is just the study of linear functions from one finite dimensional space to another finite dimensional space. And you'll learn what these things are later on in the course. So the first thing we're going to cover is linear equations and matrices. So linear equations and matrices. I know I spelled that wrong. But here we go. This is in English, this is math, so let's do it. Alright, so what do we want to know for systems of linear equations? Or what is an example for a system of linear equations? Well, let's get one example where we have a1, x1, plus a2, x2, and let's say this will go on for any an value to the xn value. These values right here, n, just means that I could keep plugging in numbers like a3, a4, a5, so on and so forth. And let's say this just equals some arbitrary value b. So, when this is expressed in real or complex quantities of b in terms of unknowns, these are our unknowns, or you can switch it around either way. It really doesn't matter too much. But what we are going to be generally finding here is the solution to these linear functions. So solution to the equations is a solution to equation is a sequence of n numbers, and we can call this anything. Let's call it S1, S2, S3, and so on and so forth to the Sn value, which is pretty simple. And what we want to find is where x1 equals s1, x2 equals s2, etc., 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 etc. Alright, so a couple of important things you're going to need to know. When we have a value for b, right over here, and this value for b, when b has no solution, or the system has no solution, when the system has no solution, b is said to be inconsistent, or the function is, let's write that in different terms, inconsistent. And when it has a solution, it is said to be consistent. So when the system has solution, it is consistent. It is consistent there. Now, two other important terms. In this case, where we have them all equaling 0, let's say b equals 0, this is known as a homogeneous system. So when b equals 0, and all the b values equal 0 to all the solutions of linear functions, b equals 0, known as homogeneous system. Now there's two types of solutions to the homogeneous systems that we're going to get, and that's going to be trivial and non-trivial solutions. When these values of x1, x2, xn, so when x1, x2, and let's just say all those values equal 0. It's a solution to a homogeneous system, but it's known as a trivial solution. So this is a trivial solution. And when they're not all 0, so when not all 0, 0, it's called a non-trivial solution. Non-trivial solution. And these are really important terms because later you're going to need to know exactly how non-trivial and trivial solutions relate to everything from determining the determinant to your subspaces, column spaces, null spaces, everything. It all comes back to those basic things. So this is just an introduction to system of linear equations. And the next videos will just be subsequent examples following it, and I'll be showing you how to work everything out.